Alright, welcome back. So now we're going to look at the actual trainer.py file. Alright, so we'll make a new file in the backend called trainer.py. Alright, so then we'll want to import duckdb. This is going to allow us to do the SQL that we need, and we'll import joblib, which will eventually let us save what we need. Right, so the first part here is that we're going to want to actually get the data. So we'll use DuckDB to get the data from the athletes table. And then what we're going to do is we're going to select everything with this query. So we're just going to focus on these couple features right now. Notice we're including run 5K in here. And that's because when we're actually training the model, we want to see what the actual value is, what the actual run 5K is, if it exists, because then if it exists, then it will allow the model to create the patterns. So we'll convert all of that to a data frame, and then we will just drop everything that's null in that data frame since we can't train on that anyway. Next, we want to actually specify what we're going to be taking for. So this query gives us a big data frame, but run 5K, which is in machine learning, it's referred to as a labeled value because it is what the answer is. We're going to want to split that into variables. By convention, it's this capital letter X here is basically the list of all of your all the features that you're going to input, and then this Y is going to be the label that you want. Now, notice that we had one feature in our plan that we haven't included in here yet, and that is specifically the gender. And that is because it's coded as, right now it's coded as string values, so male or female or null right now. So what we need to do is linear regression expects everything to be a number. So we need to actually encode that. So yes, we'll include gender in the SQL query here. And yes, we'll include it in the feature list. What we need to do in between here, though, is we need to actually encode this as a numeric value. So we're going to have this code here, which is basically going to convert everything to lowercase version and say if it's male, it's 1. If it's female, it's 0. And if it's null, then it's also going to be filled in as 0. It's worth noting, too, that we are using double bracket syntax when we select everything here. And this is because in machine learning, the list of x's are expected as either vector or matrix. And what that basically means is it's just going to be a list of numbers. The double brackets turns it into a column vector. And so that's why we want the double brackets there. So we have the list of numbers there. And then we have our label, our Y value. So now that we have our features and our labels here, now we need to actually start the training process here. So we'll import these two from scikit-learn. So a gradient boosting regressor it's an estimator. An estimator in scikit-learn terminology it's what's going to actually find the relationships that we have between back squat and run 5K, deadlift and run 5K, etc. Most machine learning is built on something called gradient descent, which in mathematics is how you find the most optimal solutions to a problem. So that is kind of what this does behind the scenes. Is gradient descent will continuously iterate and update its weights to be able to find that most optimal solution. To illustrate train test split, let me just put down the next line of code first. So, okay, so you've got your train test split. Now, this is, as you can see here, it's returning a tuple of 2 training values and 2 testing values. So in machine learning, and linear regression specifically, we train data into 2 groups. So we have our training group and our test group. So our training group is what it actually learns, where the data actually learns to find those patterns. So then it generates weights from that and it says, okay, this is what I found. Now let's take this test set, which is a separate set of data based on the input as well, and it makes guesses based on that. And since we have the labels for that, the y values, we can actually see, like, okay, how close is everything to the actual number. So through those relationships that it found on the training set, as it applies that to the test set and gets the answers of like how far away it is, that's how it generates that loss function on each iteration, which I alluded to in the past video. And we will actually print that out here so that you can see how that works. Before we actually analyze the loss function, we have to actually call the code that will actually train the model. So that's these 2 lines right here. So we're calling the gradient booster regressor. Now, n estimators and the learning rate are, those look like parameters to the function. In machine learning, they're referred to hyperparameters. So hyperparameters are just their parameters on the entire model. The reason they're called that instead of just parameters is parameters, as you might have heard like in the news, like ChatGPT has X amount of parameters or something, and it's something in the like billions or trillions, whatever it is on that. That refers to like the actual weights that are going on within the model, which are in that magnitude of numbers. The hyperparameters here are what acts on the entire model. So n estimators is telling you how many, it's telling the model how many iterations you're going to make to be able to find the actual values that we want. And then the learning rate is, that's a special value where each time that we make a new iteration, it's going to apply some factor that we choose to be able to try to get to a better number. And basically, and these parameters, these just take a lot, or hyperparameters rather, are, these just take kind of trial and error to figure out the best ones, and we'll see that in a minute. And then verbose equals 1, that's just a normal Python parameter here, which is just saying that we want to like see what's going on. And then model.fit, the infamous model.fit, is that's where we actually fit the training data to be able to find the values, hence the method name fit. And that's what's actually going to find the weights for us. Now that we've actually fit and trained the model, now we can actually include code to analyze the loss at each step. So this code here will basically, it'll look at the training output that it has, all of it. It'll iterate through each one, and then it will find the actual loss involved in that. And lastly, we will call joblib to save the actual model. As you can see, we're saving the actual model object. So that's that pickle that I was mentioning before, pickled object. It'll just retain all of its attributes and everything when we load it from this file. So this should be able to give us enough to actually run this. So uv run, and then Python trainer.py. And then one mistake is we just need to fix the path up here to point directly to athletes.db. And then I guess that we got this printed out twice here, the loss function, so I guess we actually don't need this guy here. Verbose takes care of that for us. But as you can see, you see these losses go down on each iteration, which is what you want to see. We can improve this a little bit, which we'll look at in the next video. So thanks for watching, and I'll see you in the next one.